Hey guys, sorry I logged into my Slack late and saw that there was quite a few conversations going on, and I wanted to respond to some of those. It looked like you got your questions answered by Nick, which I really appreciate him helping you all out. But I still wanted to go over some more of that stuff in the review and give you my Git and a few other websites that I think will be really useful. So Rebecca, you asked about the documentation, and he showed you certain uh, the string and the array uh, directory. I'm going to give you guys the big overview of the Java 8 API and the extensions, and it goes over lots of really interesting things that are really handy. You've got your java.io, which is the extension you'll use for reading or writing the files that you create locally on the machine. There's SQL stuff, there's security for encryption, and there's a vast amount of resources available in this, and it can get overwhelming, and a lot of the language doesn't make sense, and you will have to kind of Google some of it and just put Java, whatever syntax or expression that is confusing you, and you'll get a response. But very powerful resource. And if you want something a little bit prettier, the W3 Schools has a great option as well. You go through there, you can do a few run examples, and it's definitely not a bad site to use. I know I've said that before, but just reiterating it. Also, Codabby, I showed you this before, and once again, still great. Also, there's a more mathematical heavy one, and I know that you said, Andrew, that you were looking more into some data analytics or some sort of math stuff, and this is more pretty advanced math stuff that'll look good on you being able to say that you can prove that you can do these concepts. And I know that was a big question for you. So also I've got my Git here, which I will post in Slack right now. Actually, and it's public, so you can pull from it, and there's that. So let me show you guys this class that I created, or this application. It's called Sample Week 3, and it just uses some arrays, and I've created a few methods, and yeah, so I've got the Java utility, which is one of those things that I just showed you at that main API list, and you'll find this in there. Scanner to input any data from the keyboard. I've got to populate an array of integers, so I'm going to ask how many integers are in the array, or the string array, and then I'm going to hop through and populate, and I'm auto-populating these strings because I didn't want to have to keep typing it. So I left the code in there. If you want to actually manually input it, that'll do the same, but you'll have to comment out the SC multi, because those are the multi-dimensional arrays. Then I go through here and I ask for the size of the array of the integers and populate those. And then I go through, and this is the method I've created for this class, is add to int array, and this is where I take a new integer and I want to add it to the array. And one of the main headaches with arrays is this right here. So in order to do this, I have to create a new array beforehand that I'm going to use to populate this, and return this array from this method into this newly created array. I'm going to then reallocate memory to the original array of the new size that I need, and then I'm going to clone the new array into the original array with the new added element. It's a little weird, but it'll have a good example, and we'll step through it. Then I'm going to set that new array, which I'm just using as a way to hold these values in this new array size and everything. I'm going to set it to null because I don't need it anymore, and that way the garbage collector won't have any issue taking that memory back and using it for anything else. I output the fact that I've added the number 4 to this array by looping through the entire array, and then I delete one as well. I've got a delete int array right here where I say delete the number 4, and then I do some logic and look through that. Basically the same thing, populate the new array size based on however many 4s I deleted, and clone this new buffer, this new array thing into the original. That way I will continuously refer to the I array and not have to worry about am I in the new array or the original array. I always make sure I'm back at this I array because that's where I'm going to always access this from. And then you got to close your scanner. Don't forget to do that. So here's that first function, or the method I created. It's public static. It returns my int array. It's add to int array, and I give it the array that I want to add to and the integer that I'm adding. I go ahead and find the length. I allocate a new array with this new size that I know of. I populate every member from the last array into the new array, and then after I'm done doing that, I go to the next element and then I add the new member as well. I return this new array that I've just created back to the array, the array up here. Right here in the add. Here we go. So this is when I return it right here. Now another thing to remember with Java is this is a pass by value language. So when you pass these values, these arguments into this method, it will take a copy of it. You're not going to actually pass the real variable into there. So everything that happens inside there is inside the scope of that method. And we talked about that on Tuesday. But once again, that's where everything gets modified inside of there, and that's where all that stuff exists. And when it's done, there's no reference to it. So the modification that I make to this I array is never going to be accessible outside of the scope of this function. So that's why I've got to pass it a copy of the new thing that I created. And because I'm adding one, the old array won't be able to hold it because the size is increased, and I'll blow my stack. Now I've got another one for the string array, which I don't use, and then the delete array, which is where I go through and I loop through the entire array, and every time I find the value I'm supposed to remove, I increase this I loop to, and then I go ahead and subtract that value that I just created from the original value. So how many new members is it going to have after I remove all the 4s? Then I allocate that. Then I step through that entire array, and any one that is not equal to whatever value I'm trying to remove, I will put into the new array. And every time it hits one that is the value, I'll just skip it. And then I return this new array, which then I go back up here and populate the new array, reallocate the original array with the new length that I've got, clone it. Now I'm using my original array for all my values. This is a tedious, pain in the ass way to do memory management. It was required from the back in the old days of computer science because you would have to know how many elements of a type you would need when you compiled. These things were static. They didn't have the ability to modify memory in the same way they do now. It was years of geniuses doing really awesome things that allowed us to get this kind of ethereal with the thought process and how we manipulate a computer. But this got carried over from it. These don't really act the way they do in any of the other, or excuse me, in the C and the C++ world. These functionally do very different jobs. Here it's really cool. It's syntactically the same. It's friendly. It's familiar. But there's some black magic under the hood that just does stuff. Look into it. Try to figure out some of that stuff. But first, let's get the syntax and the functionality down. Yeah. So loop through all that, and then I also put in some outputting the string here that I dynamically created up there, as well as the multi-dimensional array, I think. No, I didn't. Okay, so let's run it. Oh, well, you go away. Let's run this. Okay, the size of my string array, 3. Size of my integer array, let's do 6. Okay. Loop through my integers here, 0, 1, 2, 3, 4, 5s. That's what I populated. That's also what the indexes are. And then I add 4 to it. 0, 1, 2, 3, 4, 5, 4. And now I remove the 4s. So I go through 0, 1, 2, 3, 5. These are arrays. They're, yeah, I already gave a speech on that. I hope this cleared up some stuff. Ask any questions in Slack, and thank you guys for your time.